All right, so in example 1, we're going to let f of x equal x plus 3 times x minus 4 squared. We're going to determine the real number values of x that cause f of x to be 0, positive, and negative. Well, when we did our number line before, when we were graphing, what did we put on that number line?
Numbers.
What kind of numbers?
Positive.
Not always.
Negative.
Not always.
All real numbers.
We put, what I'm looking for is what were the labels of those numbers? What were they called on our graph?
The intercept.
They were the x-intercepts and the
Y-intercept.
vertical asymptotes.
I knew that.
Yes, of course.
So x-intercepts and vertical asymptotes go on that number line. Well, the same thing here. Well, I don't have a fraction, so I don't have any vertical asymptotes. So all I have to do on this one, this exact example here, then is to put my x-intercepts. So how do you find x-intercepts?
Set y equal to 0.
Yeah, set y equal to 0, which means just set your function equal to 0.
But could you put each individual piece equals 0, like x plus 3 equals 0, and then
Yes.
x minus 4 equals 0 twice?
Yes. So we're going to set our function equal to 0, which means we would have x plus 3 times x minus 4 squared equal to 0. And then what Jordan was just saying, we're going to separate them. So x plus 3 equals 0, and x minus 4 equals 0. What does that squared tell me?
There's 2 of them.
There's 2 of them, so it means it has, what's that word? Multiplicity of 2. All right, so solve both of those for x.
How was your weekend, Miss Youngblood?
All right, so we have x-intercepts at negative 3 and 4. So I'm going to set up my number line. And I'm going to put my infinities on my number line. So that's what we're going to do here is we're creating intervals. Okay? And so we have those 3 different intervals. And so we know that whatever, if negative infinity to negative 3, either all of my y values are going to be positive or negative. The same thing between negative 3 and negative 4. And the same thing between 4 and infinity. So, we need to find out where this is happening at. So in order to do that, or to find, I'm sorry, not where it's happening, but what is happening, are they positive or negative? In order to do that, I need to pick an x value that is between negative infinity and negative 3. So what's a number that's between negative infinity and negative 3? Negative 4. And guys, we're going to plug this in, so don't go drastic. I know negative 1,000 is between it, but you're going to plug negative 1,000 in and mathematically use it. So be realistic. And a number between negative 3 and 4.
0.
And bigger than 4. Or between 4 and infinity.
5.
All right, good. So just like what we did before, correct? So let's plug in the negative 4. And so I'm going to take that x plus 3 and that x minus 4 squared and plug in negative 4. And I'm going to work that out. And so just like what we did before, we found that y value there is negative 64. Which if that y value is negative 64, that tells me every x value that's between negative infinity and negative 3 is going to have a y value that is negative. Because the only way that y value can change signs to become positive is if it crosses the x-axis, which means it would have to be an x-intercept. And we have our x-intercepts listed there. All right, then let's plug in the 0. And then let's plug in the 5. All right, so we know that between negative infinity and negative 3, all of our y values are going to be negative, okay? Between negative 3 and 4, all of our y values are going to be positive. And between 4 and infinity, all of our y values are going to be positive. Where are we getting that from? Where are we saying, how do we know they're going to be positive or negative? Yeah, look at the y that we have listed. They're all going to have the same sign, okay? So like this last one, we have y equals positive 8 is our y value. So that means they're all going to be positive. The middle one there, we had y equals positive 48. So that means they're all going to be positive. And the first one, we had y equals negative 64, which means they're all going to be negative. Now, typically what you will see when you do this is your positive and your negatives will alternate. So it'd be like positive, negative, positive, negative, positive, negative, you know. But I see here we have two positives together. The only way that's going to happen is if you have multiplicity at that x-intercept. So I'm going to double check this because that's throwing up a red flag to me. When I have a positive and a positive or negative and a negative, I need to check. That 0 in there, that x-intercept is a 4. Did it have multiplicity? More particular, did it have even multiplicity?
Yeah.
Yes, so that's okay then. So that's okay. If it did not, then I would have a mistake somewhere and I need to go find it. All right, so now to answer the question, it says determine the real number values of x that cause f of x to be, and the first one is 0. Well, that's where our function was equal to 0, and where was that at? Where was our function equal to 0? What's another word for 0?
At 48.
No. Listen, what's another word for 0?
X-intercept.
X-intercept, roots, and solutions, right? So what were my x-intercepts?
0.
No.
No,
Negative 3 and 4. That's what we did over on the left there. So x equals negative 3 and x equals 4 is where my function is going to be equal to 0. Where is it positive at? Well, look here. Where does it show it was positive at? From negative 3 to 4. And then from 4 to infinity. All right, so negative 3 to 4. And 4 to infinity. And if you look at the notes online, it has it written from negative 3 to infinity. And if you were in my second period class, I went ahead and went with that. But the more I think about it, knowing what I know, 0 is not positive nor negative, okay? So it's not included in it. So that's why at the 4 it was equal to 0, because that's a 0. So that's why we're going to leave it separate and just put the and symbol between it. All right, and then C, where is it negative? Negative infinity to negative 3?
Negative 4.
Negative 3.
Negative 3.
Why?
Because that's where,
Well, and what are the x equal negative 4 and the x equals 5 for then?
oh, okay. Yeah, those were our test points, okay? Those were the ones that we just plugged in that's in that interval.
So did we just guess that?
Yeah, you just had to pick one that was between negative infinity and negative 3, and somebody told me negative 4.
Okay, understandable.
And just like that x equals 0, I just needed some number between negative 3 and 4. You could have used negative 2, negative 1, you could have used 1/2. Any number that's between negative 3 and 4, they're going to give me different y values, but they're all going to have the same sign. Okay? All right, and so we answered that question for example 1.